an important section, and it is going to be on parabolas, which we worked with parabolas some in the last section, but we'll do more applications here, and there are more applications with parabolas. A lot of things will fall into a parabolic path, and you can find the max and the min. And to maximize a function, what we'll need is the vertex. And we looked just, I think, before at some relative max and relative min, but those are going to be key points in this. All right, let's go ahead and just start with this first problem. I'm going to try at the end to save 30 minutes. I have 2 word problems to try to do. So I may cut some of the other part I picked out before then if I'm watching the time. All right, so this first problem wants us to graph 4 of these on the same grid, and we do have our standard form. This is the standard form of the parabola, and it is minus here. Your vertex is going to be HK, and so that is your important point off of this. So just for the first one, right, and this is plus, so it's going to be a -5. I'm picking off the vertex. -5 and 3 will be the vertex on this one. To graph it, I need the vertex and one other point. So what we're going to do is just plug in here. And you notice 5 squared is going to give you 25. It's going to get really big. So we want to put something negative so that this won't get so big. And I think I put a -4. So, and you could pick anything, but just you want it when it's squared not to be so big. So if I plug in a -4, so this will be our one other point. And down here, I'll just do some scratch work. So -4 plus 5 squared plus 3. So this is 1 squared plus 3, and 1 plus 3 gives us 4. So I have -4 and 4 for my second point to graph the first one. We'll go ahead and get all the info for each one, and then we can graph them all at one shot. All right, so this one is in the minus form, so it will be 5, -3 for the vertex. And if we pick a point for it, so we're going to subtract 5. I picked a 4. You could have picked something different. You could have picked a 6, would have also been okay because it's still going to square it. But I'll just use the ones I picked. So if you do 4 and 4 minus 5 squared minus 3. So this is a -1 squared minus 3 is 1 minus 3 is a -2. And I picked 4. So next one for the vertex will be a -5, -3, and to pick a point, this is plus, so you need something small. So if we pick a -4, so -4 plus 5, and square it, so that'll be 1 squared is 1, and this time it is -3. So that gives us -2, and one more, so 5, 3. So you want to be able to pick off your vertex that fast, and you just have to watch here whether it's plus or minus. If it's minus, pick it straight off. If it's plus, it's going to be negative. And so for this one, so we're going to subtract a 5. We can pick a 6 here. I didn't pick that one before. So 6 minus 5 is 1. 1 squared is 1 plus 3 is 4. All right, there's our points. Go over on the grid, I have to go down and get the tool. And remember with this tool that I have to do the the vertex first. So I'm going to do negative 5, 3. So negative 5, 3. And then I'm going to do negative 4, 4. And that's one of my parabolas. Right, another one, so I'll do my tool again. 5, negative 3. And 4, negative 2. Negative 5, negative 5, negative 3, so hit my tool again. And negative 4, negative 2. And one more, 5, 3. So 5, 3. And 6, 4. So they just wanted to show you some variations so you could match them on the same grid. I'm going to turn on my email a second and see if I'm getting anything from our class. The announcement was showing, so. And I don't have anything from any students, so we'll turn it back off. All right, next one I picked, and we don't have to graph every one of these. These had a couple of variations I wanted you to see. There's not a number here at the end on the first one, and so it would be 0. To get your form. So if there's no number here, it would be 0. So your vertex on this one is going to be negative 2 because that's plus negative 2, 0. And you would pick some other point to plug in. All right. I'll skip graphing that one so it won't take so much time. This one has a negative in front, and that's okay. That's like a negative 1 in front. And that one will turn your graph upside down. If you remember with the transformations we did, and this one also doesn't have a number at the end, so it would be a 0. So with the transformations, a negative on the outside here is going to be vertical movement. It flips it over the x-axis, so it will flip it upside down. So we can graph that one. Let's see. So its vertex is 2, 0. And then we'll need another point. So you can pick anything here to plug in, except you don't want to pick 2 because we already have that point. So if we pick a 1, right, 1 minus 2 is negative 1, and negative 1 squared. So 1 minus 2, negative 1 squared will be 1. Then you apply this negative. So that's negative 1 plus 0 is negative 1. That would be our points. Right? H of x has one thing a little different that I just wanted to point out. It is in the standard form. You don't see x minus h here. So if there's nothing to subtract, it means that h is 0. So this one, the vertex is 0, 2. So it is x minus 0 squared plus 2 to put it in the actual form. And this one is going to be the same way, the last one. J of x will be negative x squared. It just has a negative out in front. All right, so it is x minus 0 squared minus 2. So it will flip upside down. Its vertex will be 0, negative 2 for the vertex. All right, and we'll just graph 2 of these. Let's graph the one that is going to flip upside down, this one. So we'll graph G, because I picked 2 points for it. So 2, 0 will be here, and 1, negative 1. So you can see that one flips down. And let's do one more. Let's do this one. So we just have to pick something else to get a second point. So if we pick a 1, right? So if you pick 1, you plug it in. 1 squared is 1, plus 2 is 3. Right? So do our tool again. 0, 2, so don't go over, but go up 2. And 1, 3. And that one is not flipped upside down. This one would be upside down. And if you remember, your standard parabola is 0, 0 is the vertex, and it goes up this way. So these are just some transformations on that. This one is moved up 2. Otherwise, it would be the standard 1. This one would be moved down 2, and it's flipped upside down. You guys have any questions on those? All right, I will leave that problem there. It's going to mark me wrong if I check it because I only answered 2 of them. So it like the ones I did. All right. Next we have question 3. And so we have to find the vertex, the y-intercept, and the x-intercept of the parabola that is defined by this quadratic. Right. This is standard form, so your vertex is easy. It's in the form minus, so it's going to be 5, negative 48. So that we just pick off. The y-intercept is also pretty easy to do because for y-intercept you plug 0 into x. So would be 3 times 0 minus 5 squared minus 48. So negative 5 squared is 25 times 3, so it's getting pretty big. So I have 75 minus 48. And gives us 27, right? The x-coordinate was 0, so 0, 27, because they want that put in that way. Right, and let's just put the 2 that we have. So for the first one, they want it in the xy form. So we'll use parentheses, 5, comma, negative 48. And I could have just shown you guys that answer. But we'll follow through since we started. Right, the x-intercepts are harder to find, and some of these are nice on the calculator, some of them are not. This one would have been okay on the calculator. Actually, it would have been hard on your calculator because of where your vertex is. That's going to be way out of your range. So let's do the x-intercept by hand on this one. Right, x-intercept says y is 0. So you're going to set 0 equal to this. And we're working with a quadratic equation here. You don't have a plain x term. You have something squared. So if we isolate that square, we can do the square root method. So let's add 48 to both sides. Divide out the 3. So 3 into 48, I believe, goes 16 times. I better write it. And then I'm going to take the square root of both sides. Remember, when you do it here, you get plus and minus. And 16 is a perfect square. So we're getting plus and minus 4. When you take the square root here, it will cancel out your exponent. So you just have to add your 5 to both sides. And I'm going to put it in front of the plus and minus. So when you have plain numbers, you work them out. So 5 plus 4 is 9. And 5 minus 4 is 1. Now, these are separate points. And we put 0 into y. So 9, 0, and 1, 0 are our intercepts. And we'll just look at the key. 1, 0, 9, 0. So we're good there. Sometimes that part can be hard. Let's look at the next one. So this is question 4. And so we have f of x. And by saying that something's hard, the calculations just are not really fast. Okay, that's what I mean by hard. All right, so we have a parabola here, something squared, and it's in standard form. You can pick off your vertex. Your vertex is -8, -25. And that's our first question. And so we're good there. All right, y-intercept. Y-intercept is plug in 0. So you'll have 8 squared is 64. Then you have the minus 25. So this looks like a -89. As an ordered pair would be 0, -89. Good. All right, and now it asks for the x-intercepts. And so we can, for x-intercepts, we have to set y equal to 0. And again, we're in the square root method form, so we need to isolate this piece that's squared. So add your 25 to both sides. Right. You have to get this negative off. It's a -1 multiplied, so divide by -1. So if -25 equals x plus 8 squared. Right. Now we're going to take the square root of both sides, and you should have an idea here that this one is not going to give us answers. All right, and taking your square root over here takes your exponent off. This is going to give you an I, so it's going to give you plus or minus 5i. and we'll subtract the 8. So negative 8 plus or minus 5i is the solution. But on your graph, you can only see real numbers. This is not a real number. This is a complex number. So your answer here is going to be does not exist. And what this means for your graph is that it's going to either be above, so your vertex will either be above or below the x-axis. And if we look at it, our vertex is 0, negative 89, so it's not going to be so nice on our graphing calculator. It'll be way out of range. And it's turned upside down, so it looks like this. This negative makes it turn upside down. Way down here, not drawn to scale, but looks like this. It never crosses the x-axis. So that's what this would mean for it does not exist. So sometimes that will happen. Right, 5 is our first one that is not in the standard form. And you could make it to standard form. We don't even teach that in this course because it's a lot of work. And if you're going to graph a parabola, because it's a symmetric figure, what you need is the vertex and one point, and then you flip it over that axis of symmetry to get a second point, and you need to know which way it opens. But those are easy to find. So for this one, we will use the formula to find the vertex instead of completing the square, which is what would have to happen to go to the other form. We would have the answer done before we ever get that piece finished. All right, so your formula to find the vertex. So this is important. You want to make sure you memorize it. It's negative b over 2a. So put it in your general form here, ax squared plus bx plus c. Pick off your negative b over 2a. That's the x coordinate of the vertex. The y is f of that. So then you plug it in. All right, so to get our vertex, it's going to be negative 6 over 2 times 1, which will be negative 6 over 2, which is a 3, negative 3. Then we have to do f of that, so we're going to plug negative 3 in. So we're going to have negative 3 squared plus 6 times negative 3 plus 34. All right, so we have 9 minus 18 plus 34, negative 9 plus 30, yes, plus 34. 25. All right, let's make sure we're good here. So our vertex is negative 325. See, we had to do a little more work than just picking it off there. Y-intercept. Y-intercept is really easy from this form because you're going to plug 0 into x. This wipes out, it's your constant. Okay. So from this form, the y-intercept is very easy. So it would be 0, 34. Right, and then they're going to ask us for X-intercepts. And so that is you plug 0 into y. I'm just recopying so these notes will look okay. And if this would factor, it would be nice. It doesn't factor. You can play with it and try. And so here you actually had to do quadratic formula. You also could test it in your calculator with that vertex that we had. It's kind of big, it's out of range. So we would have to play a bunch with our window to find that. So we'll go ahead and do our calculation here to find it. If factoring doesn't work, it's quadratic formula. So we'll go with that. So A equals 1, B equals 6, and C equals 34. All right, so your formula, X is equal to negative B, and I'm just going to plug it in as we go. So negative B plus or minus the square root, B squared minus 4 times A times C over 2 times A. So we get negative 6 plus or minus 36 minus, and we have 4 times 1 is 4 times 34 minus 136. And if you start to get pretty clever with your quadratic formula and looking at your answers, if you get negative under your radical when this is cleaned up, you're going to get I's for answers, and that is what is going to happen here. So negative 6 plus or minus square root of negative 100 over 2. You can keep going with that, but you actually don't have to for this answer. And it would simplify more. We'll just clean it up. So you would land there. But when you get the I, that's a complex number. It's not going to be on your real number grid. So it is not going to exist. So it'll either be above or below the x-axis. Let's see. This one opens up because it's a positive 1 in front of the a squared. So it's going to look like this. Our vertex is negative 325. So it is up above. So it's to the left, but it's up above your x-axis. It never crosses it. So this is going to be, does not exist. Right. 6 is one that we can put in the calculator. So it looks really nasty when you first look at it with a 98 there, really. Whoops, I left the X off. All right, so we'll go ahead and find the vertex. It is a parabola. It's going to open up because this is a positive 2 here in front. And so we want the vertex. You want the direction it opens and the vertex. So vertex will be negative b over 2a. And then plug that value in. So negative b, so it'll be 28 over 2 times 2. So 28 divided by 4 is 7. And so then we have to plug 7 in. And you have to be careful there. Watch order of operations. Exponents go before multiplication. So you have 2 times 49. And then we have to work all that out. So I'm not going to pull the calculator up there. We're just going to, I'm going to work it real quick. 2 times 49 is 98 minus 28 times 7, 196. plus 90. Right, why did I get a minus here? I should not have a minus 98 here. 2 times 49, there's no reason to have a negative. We'll just make that a equals, okay? All right, so 98 minus 196 plus 90 is negative 8. So this is our vertex, 7, negative 8. That is our first question. Y-intercept, you're plugging 0 into X. 0, 0, 90 is your answer. Right, and the X-intercepts, this one will actually factor, and I made a note to pull the graphing calculator. So I will pull the graphing calculator. Okay, it doesn't like my pen. Let's see if I can get my mouse on there. Come on, you little joker. All right, so 2x. Let's see if I can get my mouse over there. Sorry, it's my tool. It worked. Actually, I didn't do it on this template thing. I did it on my calculator. 2x to the second minus okay, we're going to ditch this idea. I'll give it one more second. Sorry. Okay, we're going to let that go and do it by hand because I need the calculator for some other things. I can put it on a different screen and share a different screen and get the mouse there. All right, sorry about that. Let's see where I was. Okay, X-intercept, we said this one will factor. And you can take that 2 out because all the terms are even and you always want to watch for that. So we're finding the X-intercepts 0 is what you set y equal to 0. And because these are all even, you can divide everything by 2, which will still leave you 0. And it gives you something much nicer. And this one will factor. So like signs both minus. And we can use 9 and 5. Then you set each one of these equal to 0. Add your 9. And here add your 5. So we're going to have 2 places where it will cross the x-axis at 0, 9 and at 0, 5. And let's just make sure Mrs. H has this right. 5, 0. Well, I put them in the wrong place, so you should not do that. Let's erase that. That calculator got me rattled, huh? 9, 0, 5, 0, because they're on the x-axis. All right, next one I picked. So I'm going to go a little faster here. I'm going to go down to 10. I just wanted to mention something on it. All right. And we probably needed one of those other ones there. But for this one, these are some questions they're going to ask us. And they're going to ask about the maximum, the minimum, and domain and range. So on this one, I just wanted to mention on it that it's easy to get your vertex from your standard form. So sometimes they'll be like this, where you pick it off. It's -5, -1, right? The other thing on it, just you don't always have to go to that formula. If it's in this form, definitely use this form. Right. So your vertex is -5, -1. And this one, because it's a positive in front of it, it is going to open up. That is your question about which way it opens. This will have, I'm not sure if this question asks it. Doesn't ask the max or min. That's on the other. If it asks, does it have a max or min, it will have a min, which is here. It will be at -5. The value will be -1, just like we did with max and min with the relative ones before. This one, let me go ahead and just work this since I skipped a bunch of those others. I had planned to do a couple of others. So we'll keep going on this one. I was only going to mention it's easy to get the form. So this one opens up, right? Determine your vertex. We already did. We just looked at it and found the vertex. Right. Y-intercept, 0 in. 5 squared is 25 minus 1 is 24. So it should be 0, 24. X-intercepts, I'm going to pass on that one because we've done that a few times. Axis of symmetry. The axis of symmetry is through your vertex, and it's going to be the vertical line x equals -5. And so, knowing your vertex, you find one other point, any point you want, and then it will flip across this line x equals 5 because it's symmetric and give you another point, which you don't have to graph. Right, they ask us to find the domain and a range. From the picture, it's easy. Let's see if we can get the picture on there. I need one more point to get the picture. All right, so let's pick a -4 because we're going to square this. So get one more point. So negative 4 plus 5 squared minus 1. So that's 1 squared, which is 1, minus 1 is 0. So an extra point is negative 4, 0, which is actually an X-intercept, okay, if we had found those earlier. Let's put those on, all right, and draw our graph so we can see the domain and range from your graph. All right, so negative 5, negative 1, and negative 4, 0. Okay, and this does open up, which we expected. Now, your domain on a parabola is negative infinity to positive infinity. That is not going to change. Your range is determined by which way it opens and your vertex. That will either be the highest point or the lowest point. So when it opens up, it's going to be our lowest point. It will touch it, and it is the y of your vertex if you don't have a picture. So it is negative 1 to infinity. We'll just make sure that one's right. Okay, so that is question 10. Let me go back to 7 just to make sure you see all the kinds of questions. All right, so when you see this one is going to be more work to get your vertex because it is not in your standard form. It's in this general form. So your kinds of questions you're going to get over here, right? Number 1 is it's a negative in front, so it's going to flip over and open down. Right. Our vertex, we have to do negative b over 2a. It's not too hard here because the numbers are not huge. So negative b, so that will be 4 over 2 times our a is negative 1. So 4 divided by negative 2 is negative 2. Then we have to plug that in. And so that gives us do your exponent first, which will give us 4, and bring this down. This will make a plus. So we have 4 minus 3 is 1. So our vertex is negative 2, 1. Okay. And then it asks us about max and min. All right. Since it opens down, we determined that by the sign here, it's going to have a max. And the y-intercept, we could get the y-intercept off without much work. 0, 0, negative 3. Good. X-intercepts, I'm going to skip. You can see what they are. There they are. So this one would factor easily. You could take that negative out, and it will factor if you set the 0 equal to that. Your axis of symmetry is going to go back to your vertex. So x will equal negative 2. And it gives the domain and the range. Domain is negative infinity to positive infinity. For our range, if we don't have the picture, because some of them you'll do it without the picture, all right, we know it's a max, and we know this is the vertex. So your range is going to come from negative infinity the highest point on it will be -3, and you're going to touch that. I'm so sorry. I picked the Y-intercept. I should have put vertex here. So it goes to 1. All right. I am going to leave those 2 word problems off, and I'll do them for you in a little bit. I'm going to go ahead and not skip and just do the others I had picked out. So question 12 I had picked. Actually 11. I just wanted to make a comment on it. On this one, just remember you can move your equation around. Right? This one, just move it over. And then you'll be able to do the problem. So remember that you can rearrange it. All right. Question 15 is one I did have picked out. Right, and this is just giving us, if we had this, a generic quadratic, and all we know is the vertex is -15, 20. We know that A is less than 0. So that means the A at the front is negative, and what that tells you is it's going to go this way. Right? So it has a max. It doesn't ask that, but it does. And then it wants a domain and range. So you will just use your vertex. You don't even have a formula for it. So it's going to come from negative infinity. This will be the highest point, which will be 20. So negative infinity to 20. Hopefully Miss H picked the right points this time. Okay. All right. And 16. We'll do that one. All right, it's just giving you different pieces, right? And it's telling us this function has an absolute minimum of -27. And it occurs at -2. If it has a minimum, that means it opens this way. And where it occurs is your x. The value of it is this one, the y. And then you could do your domain and range. Well, your domain is everything, but your range, this one, your lowest point is -27, and it goes forever up. So there you go. We will try one word problem. So I picked 17 and 18. 17 and 19. I'll try it, but if I make a mess of it, I'll do it again after when I can get that calculator to work better. So we have a person standing close to the edge on top of a 72-foot building that throws a ball vertically upward. This is our quadratic function that models the ball's height with the above the ground in feet t seconds after it was thrown. So it's going to have a parabolic path like that. Okay, and he was 72 feet up from where he threw it. So he was on top of a building over here. So this was 72 feet up. He throws it, it gets to a certain height, turns around and comes back and hits the ground. Okay, so that's what's going on. Just the kinds of questions here and what they mean as far as your picture. How many seconds, after how many seconds does the ball reach its maximum height? And so you want your vertex, right? Your vertex is a function of this time. So your vertex, right? After how many seconds, that's the x-coordinate of the vertex. So part A is going to be the x-coordinate of the vertex is the seconds. Right? And what is the maximum height? That will be the y. How many seconds does it take until the ball hits the ground? What you want to find there is your X-intercept. So we have to take the things we know and kind of apply them there. So that is basically where we want to go. And if you be sure to look in your packet, I put 2 pages, and you can, if you don't have a packet, you can look in the chapter folder in Blackboard. I put 2 pages, and one I did all my screenshots from the calculator because it did go in the calculator. We'll go ahead and work this one. So I have S of t equals negative 16t squared plus 136t plus 72. And we want the vertex. So we'll do negative b over 2a. So not such nice numbers. Negative 136 over 2 times negative 16. And you see this one's going to go down like I drew it because of this negative in front. And so we have negative 136 divided by negative 32. And I believe we get 4.25. I'll double check that. Yes, 4.25. All right, and so that was our first answer. After how many seconds will it reach the height? And so that is actually, if you're just looking across your x-axis. So 4.25 is your first answer. Now we want the y-coordinate of the vertex. So this is where you're going to plug this in. So not so nice. And I did this one in the calculator. Let me pull it and try it one more time. Good. My mouse is there. It'll work better with the mouse. Okay. Now, the first thing is, it's not, well, I'll just show you. So, 16 x to the second plus 136 x plus 72, and we say graph. And, well, we see some things, you know, we're way out of our window. We don't see everything. What you can do to kind of see where it is, because we need the vertex, we don't see that. We can do zoom, and if you keep going down and do zoom fit, and then we can see a picture. All right, now we have to see what it changed our window to. Right, so the X scale, it didn't change, so going across is the same, but look how different your Y changed. All right, so our minimum was this and max is this, so the Y is very different there. What you can find from here is I can plug this value in easily, or I could do this math by hand. Because I have it in here, I can do second calc value, number 1, and I can tell it, okay, let X be 4.25. Enter. And it calculates for me the other piece. So I wanted you to have that, and know you could do that from your calculator. You could also do it by hand. So 361. Okay, that was our second answer, which is here. I'm not going to click on that. I did check it earlier, so it's okay. The X-Intercepts, because it pulled this up for us, let's just go back to graph. The X-Intercepts, this one you don't care about. What you care about is where that ball hits the ground. So we can try to find that on here because they didn't change our X scale, right? If they did change your X scale a lot, you would have trouble there. But this is just out to 10. And so we can find this point on here, and we'll do second calc. So I'm looking for X-intercepts now. And I only care about that 1. So what I want, I don't want intersect, I want 0. The zeros are the X-intercepts, so I want choice number 2. Right, and I think we did this on the calculator before. So you're going to do left bound, right bound, and a guess. All right, now you can move the cursor, but it might take a while to get there, to get close enough. I'm actually pretty close now. The other thing I wanted to show you here that you could do, because you know it's going to be before 10, right? You can actually enter your left bound. So let's say X, well, let's put 5. Okay. We can enter that and it will take it. We just have to make sure we're clearly to the left of that point. We are. All right. And then we can get clearly to the right of it. For the right bound, we could move the cursor past it, or we could say, oh, well, let's use 10. And then you hit it one more time for guess, and it will actually give you. So it's at 9. This would be a 0, but this is a really tiny, tiny number, and that is round off error in the calculator. So it is going to be at 9. And so 9 feet away is where it's gonna, that's how many seconds it's gonna take until the ball hits the ground. And that's right. And this one, the maximum height was the y of the vertex. This was the x of the vertex. How far out? Say it was thrown from here. Okay. And there's your vertex. That's your maximum height. This part, how far out? That's what you're finding for that first piece. And then there. And there's your X-intercept. All right. I am going to stop there, and I'll do the other word problem. I don't think I can do it in 5 minutes. So I will do it on a separate video and put it up for you guys. Thanks for coming. So we'll stop there. Thank you, Charlie. Have a great day.